Hello students, in the last video we have seen the important properties of stones which are required for construction purposes. In this video we will be seeing about the basic laboratory based tests which are conducted on stones to attain their properties. So the list of the tests are being given here: crushing strength test, water absorption test, abrasion test, impact test, acid, fire resistance test, Smith's test, crystallization and microscopic test, then finally freezing and thawing test. So crushing strength test is nothing but we have already seen in a brick that compressive strength UTM, universal testing machine, we have seen, right? The same UTM will be used, or CTM in some other place people will tell, compressive testing machine, only used for compressive load, not for tensile load or any other load. So that compressive testing machine, instead of that brick, whatever stone you want to test, you can place there. So in that machine, once you place, and in the similar way you have to provide the loading through hydraulic supply. So again, the loading gauge will indicate how much load has been provided so far, and you have to look for the stone sample for the emergence of cracks. Once the cracks getting formed, the loading will be stopped. So then people will note down how much load has been applied on the area of the stone sample. So then they will interpret, okay, this much Newton per millimeter square is the crushing strength of this particular stone sample. So then water absorption test. Similarly, in the brick we have done the same. Initial weight of a stone has to be noted down, then it has to be put up in a water bucket for a period of 24 hours. After the 24 hours you got to take it out, wipe it clearly, then you have to weigh it again. W2 will be noted down. The percentage of increment in the weight should not go beyond 5% regarding the case of stones. Regarding the case of bricks, it was 15% for first class bricks, then 22 percentage for second class and third class bricks. But still, here in case of stones, the water absorption is limited only up to 5%. Then abrasion test. So abrasion test only in the last video we have seen for measuring the percentage of wear of your stone aggregates. Yes, the same one. The name of this particular equipment is Los Angeles abrasion testing machine, because this particular method have been evolved in Los Angeles. So there they have put up the name. So how it has been done, we already seen. You have to measure weight of aggregates, and you have to put up into this particular rolling cylinder along with some steel balls. So for a particular period it will be rolling, then it will be taken out. So the percentage of wear will be calculated based on a prepared formula by putting initial weight and the final weight of the aggregates. So that is how abrasion test will be done. Then if you take impact test, so you should understand impact. In the last video we have seen the last property of your stone, toughness. So what they are calling the resistance to impact is called toughness. So here the impact test is having a separate equipment called impact testing equipment, which will be looking like this. So if you can lift this particular axis to the vertical direction, so that there will be a opening, hollow portion will be available in this cylinder, guys. So inside this cylinder we have to fill up that aggregate, the stone sample what we have to test it for impact test, and we have to lift it in the vertical direction and we have to drop it. So that dropping should be in line with that impact loading. So here you should understand what is meant by impact loading. Impact loading is nothing but sudden loading which happens for a very lesser period, but it happens with a very high intensity. So static loading is there. Static loading in the sense gradual loading over a continuous period of time, slower by slower. increasing in the intensity. But impact loading in the sense sudden application of very large amount of load for a shorter period of duration. So if you take a road, for example, road, if you make a strip, a small strip from the road, from road surface, and if you see that strip alone, that strip is being subjected under very high impact load coming from the vehicle. So for a very smaller period of time, in a microsecond, and the vehicle will pass through, but still the load which put up on that strip of road is very higher. So to test the aggregates which whether it is suitable for road construction or not, people are relying on this impact test. So this impact testing machine would also can be understood like this. So people used to put up that aggregate in this hollow chamber and they will lift it up. So suddenly they will drop it down for some 25 times. So there is a standard procedure for that. So there will be 25 blows and initial weight, final weight, the blow, the hammer, drop down hammer, what is the weight of the hammer, and all those put up in a formula, and finally finding out the impact value of your aggregate will be found out. Then acid test is nothing but similarly your water absorption test. In water absorption test, what we are finding, whether the water is being absorbed inside or not, that's what we are finding in water absorption test. In acid test, they are finding whether this particular stone can able to withstand any acidic environment, less than 7 pH. Normally people will use hydrochloric acid for this particular test. Generally, wastewater carrying pipes are having a choice for making made up with different types of stones also, right? So at that time, people used to know how much the acidic environment this particular stone is capable of withstanding without getting deteriorated for much damage, right? So there, the acid test is being an important consideration. And if you take any industry in general, pharmaceutical industry or any beverages industry, cold drinks manufacturing industry, so the process of making those product may be having a high acidic environment or high alkaline environment. So that containers, that structural chamber should have that ability of resisting against the acidic environment. So like a brick lining surrounding your steel column for protecting against fire, what we have seen in the first material. Similarly, stone work would also been provided against some structural components to make them resistant against acidic damages. So there, this acid test will be considered. How people are doing? Normally, people used to prefer HCl, hydrochloric acid. Then they would immerse your stone in that acid for a particular period of time. So before and after the immersing, they will study about the physical changes happened in the structure of the stone. So in that perspective, they can understand certain acid resistant capacity of the particular stone sample. Then fire resistance, then Smith test. Fire resistance nothing but for withstanding against high temperature scenario. Smith test is nothing but we are acquiring the stones from the rock stratum which are available under the ground surface most of the times. So some other sand based material would also be present along the surface of your acquired stones. So to understand, to get to know if it is there any sand particles are present over the surface of the stone mass, people used to conduct this smith test. Simply they will take a test tube with water and they will put a sample of stone inside and they will stir it. So if it is there any turbidity is getting generated, they would understand there is a presence of sandy particles more than the rocky particles. So in that way they would come to a conclusion. Then crystallization test and microscopic test is nothing but to study the surface morphology of your stone. So these tests are normally advanced ranges of test which will be having an unique and rare applications. So then freezing and thawing test. Freezing and thawing test is nothing but subjecting the stone sample under very higher temperature simultaneously and in a very lower temperature below freezing point. So why people are doing such freezing and thawing test on stones? Certain extreme environments are there. For example, very cold countries, very hard climate areas, we need to build up a structure or a structural component should be there to be protected. So there certain types of stones would be preferred and those stones are expected to have high freezing and thawing the characteristics. So these are all the tests which will be normally conducted on the stones. And then the uses of stones. So where are all the places stones or rocks having their applications? The stone masonry is used for the construction of foundations, walls, columns, and arches. So in general, these are all the building elements one can construct with the help of stones. And stones are used for flooring. Of course, in buildings, any type of building, there's a residential, office, or hospital or industrial based buildings, flooring is an important component where stones are having their application. So then stone slabs are used as damp proof cores, lintels, and even as roofing materials. Yes, lintels are nothing but sunshade we are having right over the windows externally extruded. So that component is called lintel. That lintel generally made as a homogeneous monolithical concrete element, or in some case they may use the stone slab also. We will see that particular third point in the second unit in detail. Stones with good appearance are used for the face works of the buildings. Polished marbles and granite are commonly used for face work. Face work are nothing but the external walls of your building, external face of your building. That's all. So of course it's a high budget profile. So where people want their building look so appealing from the external side, they may put up so much money in making the facing work. So for those facing works, so many different types of decorative stones are readily available in the market. Then stones are used for paving of roads, footpaths, open spaces around the buildings. So footpaths are nothing but smaller with pavement which is used in a private area or in any public parks like that. Stones are also used in the construction of piers, abutments of bridges, dams, and retaining walls. So what is that abutment? Bridge abutment is nothing but this particular portion. So this thing is nothing but your abutment. So in our campus, opposite our campus, we are having two couple of bridges are passing by. So there, if you notice, you can able to see this sort of abutments are available along the bridges. So that side portion, this filling of side portion will be having the sand filling inside the mass, but externally it will be having your what the stone work. You can able to see the stone only from the outside. You may think that it is fully composed of stone mass, but it's not that. Only the external lines will be provided with the stones. and crushed stones with gravel are used in base work for road work. So base course for road, we will be seeing this in detail in fifth unit in the transportation domain. And crushed stones are used in the following work: basic inert material in concrete. Yes, concrete is a very much important application where stones are having for making artificial stones and building blocks and railway ballast. Railway ballast we have already seen, and concrete is an important application where stones are being used. We will be seeing concrete in detail in upcoming sessions, right? So these are all the testers and uses of stones.